Hello children, welcome to the second session of Playing with Numbers. Let us start today's class with a warm-up activity. Do you know multiplication tables? Now tell me fast. 5 into 5 is equal to? You are right, it is 25. 15 into 15 is equal to? Yes, it is 225. Now tell me, what is 25 into 25? Why are you taking so long? Are you multiplying? Yes, it is 625. Children, now observe the sums I have given you for multiplication. Do you find any similarity in this? Yes, you are right. You have 5 in the units place and the number in the tens place of each sum is the same. The product of these kind of numbers are called square numbers. Let us learn the easy method of finding a square of a number having 5 in ones place. Take 35 into 35. Here, what is the number in the ones place? 5 and 5. Find the product and write it in the ones and tens place of a product. Now, what is the number in the tens place? 3. Find the next consecutive number of 3. 3 plus 1, 4. Find the product and write it in the hundreds and thousands place of the product. 35 into 35 is equal to 1225. Let's try with the one more sum. Now, what is the number in the units place? 5 and 5. Find the product and write it in the units and tens place of the product. Now, what is the number in the tens place? 9. The next consecutive number is 10. Find the product. 9 tens are 90 and write it in the place of 100 and 1000 of a product. Therefore, answer is 95 into 95 is equal to 9025. Try these. Yes, you are right. 5 5s are 25 and you have 6 in the tens place. 6 and the next number is 7. Therefore, 6 sevens are 42. The answer is 4225. Find the product of 85 into 85. Yes, once again you are right. 5 5s are 25. The next consecutive number of 8 is 9. Therefore, 8 9s are 72. Answer is 7225. Okay children, now check yesterday's homework and make corrections if any. Try these, page number 2, main 1 and 2. Page number 10, question number 2. Children, in this session, we are going to discuss about the reason for rule of divisibility by 5, 10, 9 and 3 by writing in expanded or generalized form and solve the problems based on the divisibility rule of 5, 10, 3 and 9. To begin with, tell me the divisibility rule of 5. Yes, you are right. If a number is ending with 0 or 5, then it is divisible by 5. You know the divisibility rule for 5. Now let us explain how it works. Take an n digit number CBA and expand it. Yes, it is equal to dot 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 plus 100C plus 10B plus A. For the number CBA to be divisible by 5, all the terms of the expanded form must be divisible by 5. Here 10, 100, etc. are divisible by 10. So, here 10b, 100c are also divisible by 10. Similarly, these are divisible by 5 because 2 5s are 10. Now, the remaining term is, yes, you are right, it is A, the digit of ones place, isn't it? For the given number to be divisible by 5, the digit in ones place must be divisible by 5. Therefore, A can take the value 0 or 5. Now, let us solve a problem based on divisibility of a number by 5. If the division n divided by 5 leaves the remainder of 3, what might be the ones digit of n? Let the number n be a n digit number CBA. Here, given that when n is divided by 5, it leaves the remainder 3. Therefore, when we divide the digit of a unit's place by 5, it must also leave the remainder 3. Let us divide A divided by 5. 5 zeros are 0, remainder is 3. Therefore, A minus 0 must be equal to 3. That implies A is equal to 3 because 3 minus 0 is equal to 3. Now, once again 5 ones are 5, you get the remainder 3. A minus 5 is equal to 3, that implies A is equal to 8 because 8 minus 5 is equal to 3. Therefore, A can take the value 3 or 8. Now, let us take one more sum. If the division n divided by 5 leaves the remainder of 4 and the division n divided by 2 leaves the remainder of 1, what might be the ones digit of n? Here, let the number be CBA. Given when n divided by 5, the remainder is 4. Therefore, if we divide the digit of the units place by 5, it should give the remainder 4. Let us divide 5 zeros are 0, remainder is 4. Therefore, A minus 0 is equal to 4, that implies A is equal to 4 because children 4 minus 0 is equal to 4. Again divide A by 5, 5 ones are 5, the remainder is 4. Therefore, A minus 5 is equal to 4, that implies A is equal to 9 because once again 9 minus 5 gives the difference 4. Therefore, ones digit A must be equal to 4 or 9. Take the second part of the sum. When n is divided by 2, if the remainder is 1. When the n is divided by 2, if the remainder is 1, that shows that the given number is, yes, odd number. So, here we have only two options. A can be 4 or 9. So, which is the odd number? Yes, you are right. 9 is the odd number. So, A must be equal to 9. Therefore, ones digit of n is 9. Now, let us recall the divisibility by 10. If the ones digit of a number is 0, then the given number is completely divisible by 10. Let us check how it works. Consider a n digit number and expand it. CBA is equal to ... plus 100C plus 10B plus A. Now, for the number to be divisible by 10, all the terms of the expanded form must be divisible by 10. Here, You can see 10, 100 are the multiples of 10, therefore divisible by 10. Similarly, 10b and 100c are also divisible by 10. Now, the remaining term is a. A is divisible by 10 only if it is equal to 0. Hence, the divisibility by 10. Children, let us test the divisibility of the following numbers using divisibility rules. First number 1825. What is the number in the units place? 5. It is a odd number. Is it divisible by 2? No. 5? Yes. 10? No. Take one more number, 346. You have an even number in the units place. So, it is divisible by 2 and not divisible by 5 and 10. 510. You have 0 in the units place. So, it is divisible by 2 also, 5 and 10 also. Now, 1108. You have 8 in the units place. So, it is divisible by 2 and not divisible by 5 and 10. Children, observe here the number which is divisible by all the 3, that is 2, 5 and 10 has a 0 in the units place. In previous class, I had given an activity to look at the example and complete the table and give your conclusion. Children, check your answers. First number is 6132. The sum of the digits is 12. It is a multiple of 3 and the number is also divisible by 3. Second number 724. The sum of the digits is 13. It is not a multiple of 3. When divided by 3 gives the remainder 1. Therefore, it is also not divisible by 3. Third number is 678. Sum of the digits of a number is 21. It is a multiple of 3. When the given number is divided by 3, it gives no remainder. Therefore, it is divisible by 3. Last number 215. The sum of the digits is 8. It is not a multiple of 3 and the given number is also not divisible by 3. The conclusion. Therefore, children, if the sum of all the digits of a given number is multiple of 3, then that number is completely divisible by 3. So, through this activity, you have come up with a divisibility rule for 3. Do you remember? There is one more number which has the same divisibility rule. Yes, you are right, it is 9. Now, let us check the divisibility by 9 and 3 by taking an example. 3573. Expand it. It becomes 3 into 1000 plus 5 into 100 plus 7 into 10 plus 3. Now, here split 1000 into a multiple of 9 and a number. Yes, you can split it as 999 plus 1. Similarly, 100 as 99 plus 1 and 10 as 9 plus 1. Now, we can rewrite it as 3 bracket 999 plus 1 plus 5 bracket 99 plus 1 plus 7 bracket 9 plus 1 plus 3. Now, use the distributive property of multiplication over addition. The first term becomes 3 into 999 plus 3 and the second term becomes 5 into 99 plus 5 and the third term becomes 9 into 7 or 7 into 9 plus 7, and the last term write it as it is, plus 3. Now children, group the multiples of 9 together and the remaining numbers together. We get 3 into 999 plus 5 into 99 plus 7 into 9, then plus 3 plus 5 plus 7 plus 3. Here, look at the first 3 terms. They are multiples of 9. Therefore, they are divisible by 9 and 3. Now, we are left with the last term 3 plus 5 plus 7 plus 3. For the number 3573 to be divisible by 9 and 3, the sum, that is 3 plus 5 plus 7 plus 3, must be a multiple of 9 and 3. Let us find the sum of these numbers. 3 plus 5 plus 7 plus 3, yes, it is equal to 18. These are nothing but the sum of the digits of a given number. Now, 9 twos are 18. Therefore, 18 is a multiple of 9. 3 6 are 18. Therefore, 18 is a multiple of 3 also. Therefore, given number 3573 is divisible by 9 and 3. Now, let us test the divisibility of 9 and 3 for a n-digit number. Let us consider a number CBA and expand it. CBA is equal to 100C plus 10B plus A. Now, split 100C as 99C plus C and 10B as 9B plus B and rewrite. It becomes 99C plus 1C plus 9B plus 1B plus A. Now, regroup the multiples of 9 together and the remaining terms together. We can rewrite the first two terms, that is 99C plus 9B, and take 9 common. It becomes 9 bracket 11C plus B. Now, write the next term as it is, C plus B plus A. Here, 9 bracket 11C plus B is a multiple of 9, therefore divisible by 9 and 3. Now, the remaining term C plus B plus A. If the CBA has to be completely divisible by 9 and 3, then the sum of the digits of a given number, that is C plus B plus A, must be divisible by 9 and 3. Hence, the divisibility rule of 9 and 3. Children, let us solve a problem based on the same. Check the divisibility of 3576 by 9 and 3. First, take the number, find the sum of the digits. 3 plus 5 plus 7 plus 6 is equal to 21. Is 21 is divisible by 3? Yes, because 3 sevens are 21. Is 21 is divisible by 9? No, because 21 is not a multiple of 9. Therefore, 3576 is divisible by 3 and not divisible by 9. Now, let us take one more problem. If 64y5 is a multiple of 9 where y is a digit, what is the value of y? Now, children, let us take the number 64y5 and find sum of the digits of the number. 6 plus 4 plus y plus 5 is equal to 15 plus y. So, if the number has to be divisible by 9. This has to be a multiple of 9. It is possible only if 15 plus y is equal to 9, 18, 27 or 36. So, the value of y is equal to minus 6 if 15 plus y is equal to 9, and 3 if 15 plus y is equal to 18, and 12 if 15 plus y is equal to 27, and 21 if 15 plus y is equal to 36. But y is a digit, so y can take the values from 0 to 9 only. Therefore, y can be equal to 3 only. Therefore, we can say 15 plus y is equal to 18. That means y is equal to 3. The number becomes 6435. Let us solve one more problem. If 4, 1, z is a multiple of 3 where z is a digit, what might be the value of z? Here, once again, we have to find the sum of the digits of given number. Sum of the digits of 4, 1, z is equal to 4 plus 1 plus z is equal to 4 plus 1 plus z, which is equal to 5 plus z. 5 plus z has to be a multiple of 3 if 4, 1, z is a multiple of 3. Therefore, 5 plus z is equal to 3, 6, 9, 12, 15, 18, 21, it continues. If 5 plus z is equal to 3, that implies z is equal to minus 2, because 5 minus 2 is equal to 3. If 5 plus z is equal to 6, that implies z is equal to 1, because 5 plus 1 is equal to 6. Similarly, 5 plus z is equal to 9 implies z is equal to 4. Why? Yes, it is because 5 plus 4 is equal to 9. Same way, 5 plus z is equal to 12 implies z is equal to 7. 5 plus z is equal to 15 implies z is equal to 10. And 5 plus z is equal to 18 implies z is equal to 13. Same way it continues. Since z is a positive single digit number, it lies between 0 to 9. Z can't take the value minus 2 because it is negative, and it can't take 10 and 13 because they are 2 digit numbers. The remaining 1, 4, 7. Therefore, here z is equal to 1, 4 or 7. Children, let us solve one more problem. Find the nearest numbers to 19,506 that are divisible by 9. For this, first find the sum of the digits of 19,506. This is equal to 1 plus 9 plus 5 plus 0 plus 6. It is 21. Now, find the nearest multiple of 9 which is less than and more than 21. Now, we have 21, 9 ones are 9, 9 twos are 18. Therefore, 18 is the nearest multiple of 9 less than 21. Same way, 9 threes are 27. So, 27 is the nearest multiple of 9 which is greater than 21. 21 minus 3 gives you 18. 21 plus 6 gives you 27. Therefore, the nearest numbers to the given number that are divisible by 9 are obtained by adding minus 3 and plus 6 to 19,506. Therefore, 19,506 minus 3 is equal to 19,503, and 19,506 plus 7 is equal to 19,512. Therefore, the nearest numbers to 19,506 that are divisible by 9 are 19,503 and 19,512. Children, this concept of divisibility test looks very simple, but This knowledge is very useful and essential in solving tricky and confusing problems in competitive exams. So, you have to learn it thoroughly. Children, find the sum of the digits of 215. It is 2 plus 1 plus 5 is equal to 8. Is the number is divisible by 3? No, because it is not a multiple of 3. Is it divisible by 9? No, it is not a multiple of 9. Now take the second number 5736. Find the sum of the digits. It is equal to 21. Is it divisible by 3? Yes, because it is a multiple of 3. And it is not divisible by 9 because 21 is not a multiple of 9. Now take the next number 2184. Find the sum. The sum is equal to 15. Is this is divisible by 3? Yes, because 15 is a multiple of 3 and not divisible by 9 because it is not a multiple of 9. Similarly, find the sum of the last number 6 plus 4 plus 8 plus 0. It is equal to 18. It is divisible by 3 and also divisible by 9 since it is 18 is a multiple of both 3 and 9. So, from this we can conclude that all the numbers that are divisible by 9 are also divisible by 3, but only some numbers divisible by 3 are divisible by 9. Children, let us recall what we have learnt in this session. The reason for rule of divisibility by 5, 10, 9 and 3 by writing in expanded or generalized form, and also solve the problems using the divisibility rule of 5, 10, 3 and 9. Today's homework. Children, try these problems. Textbook page number 9, question number 2 and 3. Page number 11, question number 1 to 5. Page number 12, question number 1 to 5. Page number 12, exercise 1.2, question number 1 to 4. Children, here is an activity. Find yourself and enjoy. Look at the example and complete the table. Observe the column number 4 and 6. Give your conclusion. Here is an example. 632. What are the last two digits of the number? 32. Is it a multiple of 4? Yes, because 4 8s are 32. Divide the given number by 4. 632 divided by 4. 4 1s are 4. 2 will remain. Bring 3 down. 4 5s are 20. 3 will remain. Bring 2 down. 4 8s are 32. Remainder is 0. Therefore, it is divisible by 4. Children, complete this and give the conclusion. This class was presented by Srimati Shashireka B.S., trained graduate teacher, GHPS Narsipura, Nelmangla Taluk, Bangalore Rural District. Thank you, children.